Hello students, let us continue our discussion on motion in a straight line. So in the last session, we were discussing about graphs. What kind of graphs? PT graphs, right? We discussed few examples of graph, and we also discussed about how does PT graph look like which quantity is taken along y axis, which quantity is taken along x axis. And then now today in this session we are going to discuss one more kind of graph in motion in a straight line, which will give us more details about the motion. Okay, the new graph or the second kind of graph that we are going to take is VT graph. Okay, so what is VT graph? You all know that what is PT graph, right? P for position, T for time. That's it, very easy. So now what do you expect for VT graph? V stands for velocity, T stands for time taken. So velocity versus time graph is what we are going to discuss. Okay. So what is a VT graph? VT graph is a plot of velocity of a body along y-axis and time along x-axis. Is called VT graph. Okay. In simple, keeping it simple, we can also define it as a plot of velocity versus time is called versus time of a body in motion is called VT graph. That's also fine. Okay. So as the definition says, we are going to plot velocity along y-axis and time along x-axis. Now let me take few values and try to understand how does VT graph look like. So let me take the velocity along y-axis as 2, 4, 6, 8, 10, 12. See, this velocity is an example one. Okay, this can be anything. This can be like 20, 30, 40, 50, 60, so on. This can also be 1, 2, 3, 4. This is particular example. Okay, a random example that I have taken, but you can understand this using any example of VT graph. That's fine. So now coming to the x-axis, time axis. Let me take this as 5, 10, 15, 20, 25, 30, 35. So this is the time axis, which is in seconds or minutes or hours. So for this example, let me take time in seconds and velocity in meter per second. So now let me give you a situation, and hence we shall plot the graph for that situation. Say a body was already in motion when we start to observe the body, which means when we start the observation, the body was already moving. Okay. What was the state of the body before we started observing it? We are not bothered about it. We don't want it. Okay. When we started the observation, when we just started looking at the body was already moving. With what velocity? Say with the velocity of 2 meter per second. So, which means when time t is equal to 0, okay, when do we say time t is equal to 0? That is the time, or that is the instant in which we started the observation. Okay, so time t is equal to 0, that is the point of time, and at that point of time the velocity was 2 meter per second. It was not starting from rest, instead it already had certain velocity 2 meter per second. So time 0, x axis 0, y axis 2, and hence the point comes here. Okay, then next the body after 2 seconds, 5 seconds here. Okay, after 5 seconds the body is found to have a velocity of 4 meter per second. Okay, so after 5 seconds the body had the instantaneous velocity of 4 meter per second. Then once again I observed the body after 10 seconds, and after 10 seconds I found that the body has the velocity of 6 meter per second. And after 15 seconds I observed the body again and got to know that the body has the velocity of 8 meter per second. So this is how different points are obtained using that motion that I have observed. Now what I see is after 15 seconds it has gained the velocity of 8 meter per second, that's fine. Then I look at the body after 5 seconds more, okay, which means after 20 seconds from the beginning of the motion. Then I see that the body had the velocity of 8 meter per second itself. Okay, same velocity after 20 seconds of observation. And after 25 seconds I see that the body is still moving with the same velocity, 8 meter per second. And I see that after 30 seconds the body's velocity had dropped to 4 meter per second. Okay, then which means somewhat like a car which was already moving with certain velocity, and I see that its velocity keep on increasing for a certain time, and then the velocity becomes constant, and after a certain time the velocity starts to decrease, which means this is the case of brakes applied, right? Brakes are applied and hence velocity decreases. And after 35 seconds I see that the body has come to rest, which means 4 to 0. So now if I join all these lines, the graph starts from this point and travel like this. If I join all these lines, this is our VT graph for the motion that I just discussed. So now the reason I gave them together is you should be able to analyze a VT graph and understand what kind of motion is happening there. Clear? The intention of drawing this graph is one should understand what kind of motion is happening. Okay, so now whatever I did while drawing the graph, you do the opposite way. Now you start looking into the graph and analyze the kind of motion that is happening. So you should start thinking like, okay, when the observer has started the observation, the speed of the body was 2 meter per second, and after 5 seconds the speed increased to 4, after 10 seconds the speed increased to 6 meter per second, after 15 seconds the speed was 8 meter per second, and at 20 and 25 seconds the speed remained constant till that time, till 25 seconds, and then from 25 seconds in 25 meter per second the speed decreased to 4 meter per second after 5 seconds. Then 5 more seconds the speed decreased to 0. What do you mean by speed or velocity becoming 0? Speed or velocity of a body becoming 0 means the body has come to rest. Okay, so this is how you should be able to analyze a graph and understand the motion, or in the opposite way, if the motion is given you should be able to draw the graph. Okay, so this is about introduction of VT graph. Now we shall take few examples of VT graph and discuss different characteristics out of it. Okay, let us take few graphs now. Okay, as similar to different PT graphs that we took, now we are going to take different VT graphs here. Okay, the first VT graph that I am going to take is as follows. Vt. Say a graph which coincide or overlap with the time axis like this. What kind of motion is this? This graph represents the body which is in rest, isn't it? Because initially the speed of the body was 0, and after a certain time I observed that the speed is 0, 0, 0, 0, 0, 0. So that's it. The body is in rest. And when the body is in rest, velocity of the body is always 0. Okay, velocity is always 0, which means, in other words, I can say velocity is 0 and not changing. As long as the velocity does not change, whether it may be 0 or any particular value, as long as the velocity does not change, acceleration is 0. Okay? Keep that in mind. We say a body is accelerating only when the velocity changes. It can either increase or decrease the velocity, but it should change. Okay? Only if the velocity change, then we say the body has certain acceleration. Here it's always 0, and hence acceleration is also 0 for this motion, for this graph. Now, very simple one, so no problem. Next, another VT graph. Say a parallel line, not coinciding on the time axis, instead a parallel line, the given graph is a parallel line, parallel to time axis or x-axis. So what is happening in this case? In this case, obviously the body is not in rest, because right from the beginning of the motion till the end of the motion, the body has certain constant velocity. Say this velocity is 50 meter per second, then 50, 50, 50, 50, 50. After any time I observe, after any interval of time I observe the body, its velocity is always 50 meter per second. The same value is maintained. So the body is moving, okay, moving with constant velocity. Okay, V is constant, which means velocity is constant, it's not changing. And as long as the velocity is constant, okay, so acceleration is again 0, because velocity is not changing. Then moving ahead for the next graph, say this is the graph which we have. Now observe this graph carefully. What is happening to velocity here? Okay, velocity of the body is increasing with time, isn't it? Here, after certain time, the velocity was certain value, and after certain other time, the velocity increased, right? Velocity kept on increasing with time, isn't it? So this is the situation where the body is moving, obviously it is moving with increasing velocity. Okay, so velocity is increasing, isn't it? Velocity is increasing with respect to time. Now, what was the initial condition? Initial condition is that the body started its motion from rest, and then the velocity started to increase. So velocity is increasing from rest or from 0. Okay, 0 means the body is in rest. So here in this situation, the body has started its motion from rest, and the velocity is increasing with respect to time. Okay, fine. So this is about what is happening to velocity. And now we should also get to know what is happening to acceleration. So what is acceleration basically? Acceleration is the slope of VT graph. Obviously velocity is changing, it is increasing, that's fine. So whenever I say velocity is changing, there and all there will be acceleration. Okay. So When I say change in velocity, there are two types of changes that can happen. One is increasing change, the other is decreasing change. When the velocity increases, we say acceleration is positive. When the velocity decreases, we say the acceleration is negative. You know that, right? We have discussed about it. And now what is happening to velocity here? Velocity is increasing and hence acceleration should be positive. Yeah, that's fine, acceleration is positive, but whether it is a positive constant or a positive increasing again. So what is happening to acceleration in the graph? That should also be analyzed. As I said, velocity in PT graph, okay, the one which we discussed in the last session, in PT graph, slope of the PT graph gives us velocity. Okay, slope of PT graph gives us velocity. In the same way, slope of VT graph gives us acceleration. Okay, keep that in mind. So we should check what is happening to slope at different points on the graph. Okay, so how do I get the slope? We get the slope by constructing a right angle triangle by choosing certain part of the graph. Okay, so I'll take this part and draw a right angle triangle. So I'll take this graph, this part of the graph, and one more right angle triangle, one more right angle triangle, one more right angle. And I see that for all these right angle triangle, okay, you observe this. How do we get the slope? Say this is the graph. So this is the right angle triangle that I construct. Then slope of the line is obtained using, I should name the triangle as ABC. Then slope is defined by opposite side by adjacent side, AB by BC. Okay, AB by BC is slope. Okay, here this height by this length. Okay, height by base, height by base, height by base of all the triangles gives us slope at this point, slope at this point, at this point, and at this point. Now since the line is straight one, I don't see any variation in the shape of the in the shape of the right angled triangle that I have constructed. Okay, so I can easily say that acceleration is positive and constant throughout the motion. Okay, how do one way of understanding or deciding the acceleration is constant is by looking into the shape of the triangles. Okay, that is one way of deciding that the acceleration is constant. The other indirect method of deciding what is happening to acceleration is making use of a pen. Keep the pen at different points on the graph. Now I see that the orientation of the pen, okay, is not changed when I move ahead in the graph. Okay, orientation remains the same. When the orientation remains the same, we say the slope remains the same. What is slope of VT graph? Slope of VT graph is acceleration. So for this graph, I can say acceleration is constant. Okay. While constructing this right angle triangles, make use of pencil if you need, or else no need to construct the right angle triangle. Okay. But if you construct them, you should write these things in a note, and hence you can understand it when you take them again. I hope you are clear with this. Moving ahead, I'll take one more VT graph, example, different VT graph like this. See, these two VT graphs looks almost the similar, but the difference is in this VT graph, the beginning of the graph is from the origin, from 0, but here the beginning is not from 0, it is from certain value of velocity axis. So what is happening to velocity? Is the velocity increasing, decreasing, or same? Obviously velocity is increasing with time. Okay, so velocity is increasing, fine, but it is not increasing from rest. So for this motion, the difference between these two graphs is that in this graph the body is moving from rest. Okay, body just started its motion from rest when we started the observation. But in this part, the body had already gained certain velocity when we started the observation. The body had already, it already had certain velocity when we started the observation. Okay, so this is the motion where velocity is increasing not from rest, okay, not from rest, but from certain initial velocity. Okay, so it may be any value, like as we discussed in the example, okay, but it is not starting its motion from rest. Okay, here the body is moving with certain initial velocity. Okay, so velocity is increasing and hence acceleration is also positive and constant. Why constant acceleration? Because the slope is not changing. Okay, clear with these 4 graphs? Right. So now let us move ahead for the next graph, Vt. Okay, so increase of velocity is done, and now I'll take decrease of velocity. So in the beginning itself it had certain velocity, but now the velocity is decreasing. Okay, so velocity is decreasing, going down. So when the velocity decreases with respect to time in the motion, what is happening to acceleration? I've discussed about it. Okay, when the velocity decreases, acceleration is taken to be negative. Okay, when the velocity increases, acceleration is positive. When the velocity decreases, acceleration is negative. So velocity is decreasing and hence acceleration is negative. So how do we understand the negative acceleration using the slope? Okay, when you have such a graph and the slope shall be obtained like this, right? So now if you observe the difference between this right angle triangle and this right angle triangle, the direction of the triangle is exactly opposite, right? So, or in other words, in the same way I take ABC, AB by BC is what I take. But what we do is, here the value of AB is going to be the same as such, but one of them from the BC value, okay, what we take, the initial, okay, and the final. Okay, let me give you the clear idea itself. It takes a little time. Okay, say here the value is 5 and here the value is 10. Say here the value is 10 and here the value is 15. Okay, so velocity meter per second, time seconds. So when the slope is like this, we say directly 15 minus 10. Okay, when the slope is like this, okay, this is the graph, this is the slope. Once again 15, once again let me name them ABC, 15, 10, 5, 10. Okay, now you see here AB by BC is what we take for the slope in both the graphs. But when I take AB here, I take final point minus initial point, okay, or final value minus initial value. So it is going to be 15 minus 10 divided by, once again, final value minus initial value, which is going to be 10 minus 5, which will give us 5 by 5, 1 meter per second squared. So this is the slope. Okay, this is what is slope of this graph, positive plus 1. But here if I take the slope, see, B is the initial point, okay, along the time axis, C is the final point. Okay, now sorry, not B, okay, it's only about A and C. These two are the graphs, points on the graph. Okay, this is just the extra construction that I have made. A and C are important points. So when I take the initial point here, I should put the initial values first, or sorry, final values first, right? here which is the final point? A. So final point is A, so that is why I gave 15, okay, 10 first, minus initial values, minus 15 minus 10 the y-axis value and x-axis is 5. Clear? Final minus initial, final minus initial. So final is point C. This is the graph. Okay, in the graph, C is the final point. So numerator is for y-axis. So it's the for the final point, y-axis value is 10 minus initial point is A. Okay, because we always take the point with respect to time. Which point came first? Point A comes first with respect to time. So 10 minus 15. Okay, because final y value minus initial y value divided by final x value or final time value C, which is 10 again, minus 5. Okay, final minus initial value of time. If I simplify this, 10 minus 15 is minus 5. 10 minus 5 is 5. So minus 1 meter per second squared. Okay, be clear with this. This is the graph with positive slope, like this, increasing velocity. And this is the graph with negative slope, decreasing velocity. Okay, decreasing velocity, negative slope. Increasing velocity, positive slope. Mathematically, I have given you the idea how do we get negative slope, a negative value for this kind of graph, slope of this kind of graph. Okay. So this is about slope in detail. But what you should be concentrated on is what is happening to the slope. Okay, so slope is negative here, so acceleration is negative. But is the slope changing? Look at that. So the slope is not changing with respect to time. The orientation of the pen is not changing, it's the same. So orientation remains the same and hence acceleration is negative and constant. Okay, acceleration is negative and constant. Now let us take the next VT graph, VT. Okay, the next VT graph is like this. Okay, so similar to PT graphs. But what is happening to velocity, what is happening to acceleration? That is what we should analyze. Obviously, velocity is increasing with time, right? Increasing. So, velocity is increasing. So, as long as the velocity is increasing, acceleration is positive, right? So, when as and soon when you see velocity is increasing, you can directly go and say acceleration is positive, finished. Now, is the slope same or changing? See, if I take the slope at this point, it's pointed like this. If I take the slope at this point, the slope has increased. And I take one more point here, the slope is still increased. So, when I take this graph, I observe that the slope is increasing with respect to time. Okay, slope is increasing. I've told you that more the orientation of the slope, okay, more the orientation of the slope from the x-axis, okay, more the deviation from the x-axis, more the slope, okay. This is zero slope, okay, zero slope. Here, okay, here also, see, zero slope, zero slope, zero slope. That's why acceleration 0, okay. Zero slope, zero slope, zero slope, acceleration 0 because it is parallel to time axis, no deviation. But here positive slope, positive slope, positive slope because it is deviated in a positive direction like this. But here it is negative slope because the deviation is downwards like this, negative, negative, negative. That is why it is a downward orientation and hence negative slope. So acceleration is positive, that's right, because velocity is increasing, but the slope is increasing with time. What is slope? Slope is acceleration, and hence acceleration is positive and increasing. Okay, acceleration is positive and increasing for this graph. Clear? Okay. Next, one more graph. If I have a graph like this, okay, see, obviously velocity is increasing, that's right. So as and when the velocity increases, acceleration is positive, fine. So acceleration is positive, that's fine, but it's not constant. Acceleration, which is the slope, is not constant. See, the slope is decreasing, it is going towards the x-axis like this, right? See, here it is like this, here it has become like this. So this is how the slope has decreased. Okay, so the slope is decreasing here, like this, like this, like this. The slope is decreasing. When it comes to this position, the slope is 0, which means velocity is constant. Okay, so slope is decreasing and hence acceleration is decreasing. So for this graph, velocity is increasing, that is why acceleration is positive, but slope is decreasing and hence acceleration is decreasing. Okay, so for this graph, velocity increasing, acceleration is positive and decreasing. Clear? Okay. Next, one more graph like this. See what is happening to velocity and acceleration here. Velocity is decreasing with the time, right? So velocity is decreasing, that's fine. So as and when I say velocity is decreasing, acceleration should be negative. So since the velocity is decreasing, acceleration is negative. But what is happening to that negative acceleration? Okay, so acceleration is negative, that's fine. But you observe carefully what is happening to that negative acceleration. Okay, see, the deviation is going away. See, this is somewhat like zero acceleration because the slope is 0. And now it has started downwards like this. Okay, the orientation has started downwards. So when the orientation goes downwards, it is somewhat like going from 0 to certain negative value. Okay, let me give you an example. If the value changes from 10 to 2, what do you say? Whether it is increasing or decreasing? You say decreasing, right? That's easy. In the same way, if I say the value goes from 0 to minus 6, when I say the value goes from 0 to minus 6, then what is actually happening? Whether it is increasing or decreasing? Think over it. See, it's 0 to negative value and hence it is decreasing. If it is 0 to plus 6, increasing. 0 to minus 6, decreasing. So, here it is 0 to certain negative value. Even if it is from minus 2 to minus 6, then also it is decreasing. Okay. So, acceleration is negative and decreasing. Okay. Clear? Why did I give this? Magnitude of the velocity is increasing, magnitude of the acceleration is increasing, that's right. But you should always take the entire case together. Okay. So like what I said numerically, the acceleration is somewhat like going from minus 2 to minus 6, minus 6 to minus 8, minus 8 to minus 10. So the velocity, the acceleration is going more and more and more negative. When that happens, we say it is decreasing, that's it. Okay. So that is about the other graph. Now one more graph. Okay. So these are 8 graphs. This is the 9th VT graph that I am taking now. That happened now. So next is like this. Okay. What is happening to velocity? Velocity obviously decreasing, becoming less and less and less. Okay. So when I say velocity is decreasing, acceleration is negative. Acceleration is negative, but look at this. Initially it was very much negative, but gradually it is going towards zero, right? Like this, isn't it? Like this. The orientation went like this. So when that is the situation, it is somewhat like coming from -10 to -2. Okay. So the value is increased. Okay. So acceleration is negative and increasing. Okay, that is how you should analyze the graph. Now, 10th one, I'll combine two graphs and analyze it, okay, like this. See what is happening to velocity and acceleration in this graph. Let me take velocity first. In this graph, velocity is decreasing in the first half, isn't it? And velocity is increasing in the second half. So you can write as it is, velocity decreasing in first half and velocity increasing in second half. Okay, velocity is fine. What is happening to acceleration? See, acceleration was very much negative, okay, too much negative, but gradually the negativeness started to come down, but then too much negative to 0, somewhat like -10 to 0, okay, -10, 0. So it is increasing, and from 0 to +10, so it is continuously increasing, -10, -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, parallel, that's why 0, slope is 0, acceleration is 0, +1, +2, +3, +4, +5, +6, +7, +8, +9, +10. So it is increasing acceleration, okay. So increasing acceleration. So it's not always positive acceleration or always negative acceleration. As you can see, in the first half, acceleration is negative and increasing, okay, negative and increasing. In the second half, acceleration is positive and increasing, right? Why it is positive? Because velocity is increasing in the second half. That is why acceleration is positive in this half, acceleration is negative in this graph, but in both the parts acceleration is always increasing, okay. Next, the same way, like this. What is happening here? In the first half, velocity is increasing, okay. So when the velocity is increasing in the first half, like this, okay, velocity is increasing, and hence acceleration is positive in the first half. In the second half, velocity is decreasing, velocity decreasing in second half, and hence acceleration is negative. But in both the parts, you can see it was somewhat like good positive acceleration, which then gradually became 0, and after that it went down to negative acceleration. So somewhat like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, -5, -6, -7, -8, -10. So +10 to -10. What is happening? Decreasing. So acceleration is decreasing in both the parts. Okay, acceleration is decreasing in both the parts for this graph. Clear? Okay, so this is about 10 different graphs that we have discussed so far. Now I would like to give one trick to analyze, or it's an assignment for you, okay. You making use of this trick, you should draw the next 10 graphs, okay. So one of the graph that we had was like this, right, Vt. What are the details that I wrote? Velocity increasing, acceleration positive, okay, and yeah, that's it. Now, if the same graph is like this in the fourth quadrant, that's how you say, right? First quadrant, second, third, fourth, which means the velocity is always negative in this part, okay? Velocity is always negative in this part. So, for this kind of graph, okay, this is again VT graph again, VT graph itself, nothing else, okay. For this kind of graph, why do we get negative velocity in the first place? Negative velocity is obtained when the body is moving in the opposite direction, okay, or we call that as the body is moving in negative direction, okay. So, when the body move in the negative direction, we get this kind of graph. So, for this kind of graph, you can say, yeah, obviously, the velocity is becoming more and more and more negative, but you can say velocity increasing in negative direction, okay, that's it. See, this is somewhat like reflection of it, isn't it? This is like this is exactly the reflection of it. So, velocity is increasing, but in the negative direction, and acceleration is positive in negative direction, okay, in negative direction. Clear? Understood? Velocity is increasing. If I want to complete the sentence, then I should put velocity is increasing in positive direction. For this, acceleration positive in positive direction, okay. So, whenever you have a reflection of this graph, okay, reflection means you keep a mirror here. So, this graph is the reflection of this, isn't it? If you keep a mirror here, this will be reflected like this here. So, for this kind of graph, which is reflection of this, rest everything remains the same. Velocity increasing, but velocity increasing in positive direction, acceleration positive in positive direction. But here, velocity increasing in negative direction, going backwards, okay, and acceleration positive in negative direction. For this graph, okay, sorry. So, we are talking about negative direction now. So, Vt, what is happening with this graph? In this graph, velocity is constant, okay, constant in negative direction, and acceleration is 0 because it's constant, no? So, that's why acceleration is 0 in negative direction. That's how you should write, okay. So, this is how you should draw all different graphs, all different VT graphs, and hence you will understand in detailedly about all the VT graphs, okay. So, this is about 20 VT graphs that you will get from this session, which will be more than enough for any kind of exams, okay.